Today on How It's Made Dream Cars, the Lotus Evora, a performance sports car inspired by track racing but fit for the road. Engineers design Lotus cars at their headquarters in Hethel, UK. Modern Lotus cars are the result of over 60 years of innovative automotive engineering. Lotus founder Colin Chapman made his mark in the racing industry in the 1960s. He solidified his reputation as a leading race car builder when his vehicles won several double F1 constructors and drivers' championships. One example is Mario Andretti's 1978 victory with the Lotus Type 79. Chapman introduced the first F1 car with a carbon fiber monocoque in 1981. That vehicle illustrated his design philosophy: to add speed, add lightness. The Lotus Evora, Lotus Elise, and Lotus Exige were all designed following Chapman's motto. At the Lotus Driving Academy, car enthusiasts can experience the handling, dynamic performance, and trackability of these supercars. Stylists and designers study existing Lotus cars. They discuss the aesthetic, technological, and aerodynamic features of each model. They also consider improvements that could be made to the next generation of models. The team always keeps in mind Chapman's philosophy of enhancing performance by making the cars lighter rather than simply making them more powerful. In the styling studio, an artist sketches a model in a 3D CAD system. Layer by layer, he adds detail to the virtual sketch. A clay modeling robot gives shape to the design. The CNC-controlled end mill tool carves the clay, following precise instructions from the design system. A thick clay layer covering a modeling jig allows the CNC machine to make a coarse model. Once the robot is done, a worker finishes the modeling. The modeler brushes off the clay flakes and hand finishes the model. He uses precision sculpting tools to even out the clay as much as possible. The goal is to imitate the smoothness of a polished car body. The clay model helps designers visualize the full-sized car. It reproduces every detail of the virtual design and will be used for aerodynamic testing. The Lotus Lightweight Structures anodizing plant is located in Wellingborough, UK. This is where workers prepare the car's aluminum for anodizing. An electrolytic process forms an oxide layer on the aluminum surface. Workers begin by placing machined metal sheets onto electrically charged racks called flight bars. The flight bars run electric current through the aluminum during the anodizing process. But before this happens, the panels need to go through a degreasing and descaling bath. Now that the aluminum sheets are clean, the flight bar dips the panels into a sodium hydroxide solution. The solution dissolves a thin layer of the aluminum, opening up nanopores in the metal sheets. In the next tank, sulfuric acid is combined with an electric current, triggering a chemical reaction that leaves a coat of aluminum oxide on the surface of the metal. This corrosion-resistant layer bonds to the aluminum itself, providing protection that will never chip or peel off. Next, the flight bar lowers the anodized aluminum into a rinsing tank. Plastic balls floating on the surface of the tank prevent the liquid from evaporating. Now the rinsed aluminum sheets are lowered over an air jet. They're blow-dried before heading off to the assembly department. At the Lotus Lightweight Structures facility in Worcester, UK, an adhesive robot prepares the parts for bonding. The robot applies epoxy adhesive on each bonding point and flange. This process makes the chassis very strong and stiff. Bonding with adhesive also maintains dimensional accuracy and integrity, which cannot be achieved by welding. A worker takes the parts to the assembly department on a low-build trolley. The chassis build begins by adding machined aluminum extrusions to the assembly fixture. They assemble the triangular main chassis frame. It's designed to bear most of the vehicle's handling forces. The workers then use bending beam extrusions to form the side rails of the car. They must be perfectly aligned with the chassis. Mounting brackets are installed for the tank panel and rear torsion box. Once the chassis is fitted with the front torsion box and side member reinforcements on both rails, it's ready for assembly. The main chassis assembly line in Hethel, UK, is where skilled workers assemble the main components of the Lotus Evora to its bonded aluminum frame. A technician starts by positioning the chassis on a rollover build trolley. This tool allows him to fit parts under the chassis with ease. Next, he routes the main electrical harness along the frame, working the cables through holes in the aluminum extrusions. The harness contains cables for the electrical components of the car, including the door locks, window controls, headlight controls, fuel sender, instruments, and navigation. The technician tilts the rollover build trolley to the side and moves on to the next assembly step. There are 8 assembly stages. Each step takes just under an hour. The chassis assembly steps are generally the same for most Lotus models, but the Evora has a larger chassis with different part specifications, such as this fully adjustable steering column. Before assembling the steering column, the technician must use an electronic centralizing jib to center the steering rack. It's critical that the steering rack is correctly positioned prior to setting the steering geometry. An operator prepares the fuel tank assembly at the next station. He tightens bolts on the fuel sending unit with a manual torque wrench. Then he performs a test to ensure that the fuel pump is functioning correctly. He inserts the fuel tank in the chassis and positions mounting brackets. He uses an automatic torque gun to secure the brackets in place. He installs the tank bay shear panel under the fuel tank. It plays a key structural role and completes the rear torsion box. The panel is secured in place by first lightly tightening the bolts, then finishing the job with the torque gun. Each assembly step of the main chassis is timed to the minute. This allows the workers to move each trolley up the line in almost perfect synchronization. Before mounting the suspension on the main chassis, they first apply polyurethane adhesive to the seatbelt anchorage frame. The seatbelt anchorage includes rollover protection to prevent the roof from collapsing if the car flips over in an accident. The worker bolts the seatbelt anchorage to the main chassis using an automatic calibrated torque gun. Another worker installs the front anti-roll bar. This important part of the suspension assembly gives the car additional wheel spring rate and limits the vehicle's body roll. Workers assemble the galvanized steel rear subframe to the main chassis. The engine and exhaust assembly will be installed to the rear subframe next. At the Lotus assembly plant, technicians customize the double overhead camshaft engine and gearbox before attaching them to the rear subframe of the cars. A technician inserts the differential inside the 6-speed gearbox of the Evora. He takes the input shaft and mounts close ratio helical gears onto it. He installs both the input and output shafts in the gearbox. The output shaft connects to the differential. This transfers power to the wheels. The technician then inserts a second output shaft. He installs the reverse idler shaft inside the gearbox, connecting it to the input shaft. The customization of the gearbox is a very sensitive, high-precision task. The technician now installs shift forks over the selector collar on the shafts. These forks allow for shifting between the 6 forward gears and reverse. The technician inserts slider shafts into the forks. This enables the forks to move up or down when the driver shifts gears. Once the gearbox assembly is complete, the technician applies a strip of non-hardening adhesive sealant around the gearbox casing. Then he puts the gearbox cover in place. Next, a technician assembles a supercharger to the V6 engine and bolts it in place with a pneumatic torque wrench. Another worker joins the gearbox to the engine and inserts fixing bolts. Then a technician lowers the engine and gearbox assembly onto the subframe. He assembles the gearbox mount to the subframe using a manual torque wrench. With the help of an overhead lifting device, he aligns the gearbox with the mount and secures it in place. This finalizes the engine assembly. Workers connect the exhaust system to the engine. It's made of aviation-grade stainless steel and makes a distinctive race car-like growl. A worker holds the engine as the other bolts on the exhaust. The exhaust for the Evora comes with a signature oval tip. Next, technicians use an overhead hoist to position the engine module and subframe assembly onto the main chassis. They bolt the rear subframe in place with a pneumatic torque gun. Once the engine is firmly secured, the operators release the hoist to prepare the trolley for the next station. Joining the engine to the chassis is slightly different for the Lotus Elise. Operators install the 4-cylinder engine directly into the rear subframe. It's already attached to the main chassis. They plug the engine harness into the main harness and make the auxiliary connections to finish the process. Next comes the suspension arms assembly. The independent forged aluminum double wishbone suspension is fitted with servo-assisted ventilated brake discs, providing maximum control over the wheel's camber angle and scrub radius. It takes about a day's work to get the chassis frame fully assembled and ready to send off to the body assembly line. The body panels need to be painted before they can be assembled. Painters spray the panels with an ecological water-based primer. Workers paint them in sets to ensure color consistency. It's impossible to use electrostatic paint for the body panels because the high-tech composite material is not conductive. Painters need to apply a water-based lacquer to protect the paint coating. At the Lotus headquarters, workers get the cars ready to hit the road. Technicians push this assembled Evora to the fluid fill department for an initial fuel filling before the engine gets started for the first time. At another station, workers transfer the chassis of an Evora from a high-build trolley to a low-build trolley. They get ready to bond the painted body panels to the extruded aluminum chassis. A technician applies a polyurethane adhesive on the upper rail before the core body assembly machine attaches the side panel to the chassis. The technician prepares the front crash structure for bonding. This part covers the front chassis subframe and is designed to absorb the impact of an accident. Technicians clamp it tight until the adhesive cures. Then they bring in the composite windscreen aperture. Locator arms are used to position it correctly. Next, they fit the door to the body side panel. A technician uses measure gauges to make sure the fit is perfect. Technicians assemble the door closing mechanism called the door striker. They screw in a steel bolt over a washer to prevent damaging the composite. The striker is set to allow for a nice and smooth door closure. Technicians now bring in the rear clamshell. It only weighs about 40 pounds. The panel fits over the rear module to cover both the engine and fuel tank. The technician sets the rear clamshell flush to the body side panels. Then they install the front clamshell. The panel fits over the crash structure and has openings for the radiator vents, headlights, and flashers. With the car sitting on a two-post ramp lift, a technician installs the rear diffuser. The diffuser is designed for optimal aerodynamics, reducing both drag and lift. It prevents air turbulence from reducing the car's performance. Now, a technician mounts the wheels on cross-drilled brake discs. He roughly tightens the nuts through the 12-spoke rim before lowering the vehicle on its wheels for the very first time. The technician finishes torquing the wheel nuts with a manual wrench. He marks each one that's been tightened to the correct torque. Next, the finished car goes to the chassis dynamometer, or rolling road. This is where the vehicle goes through a complete functional testing process. Drive rollers activate the front wheels to calibrate the dynamometer. A computer prompts the driver with instructions throughout the testing cycle. Integrated calibration tools monitor and analyze the car's response. The driver moves the rear wheels onto the rollers to test various drivetrain components like the rear brakes. The computer processes the data and uses it for engine calibration. The dynamometer measures the engine RPM, horsepower, and torque output at various speeds, and also monitors the engine's response to acceleration and gear shifting. This system allows for the dynamic testing of all the vehicle's features, including emission sampling and fuel consumption analysis. The engine management software must have this test data before the car can leave the production line. Finally, the cars go to surface finishing. Workers polish and clean the car body using pneumatic orbital polishers. Low-speed dry polishing leaves a glossy finish, enhancing the smoothness and shine of the lacquer-protected color coating. These supercars are ready to be tried out. The Evora with its integrated aerodynamic rear boot spoiler, the slick convertible Elise sports car, and the Exige Coupe. The interior of the cars are upholstered in leather and feature an ergonomically shaped steering wheel with lightweight rim. Combining aerodynamic drag reduction engineering with aesthetic design, Lotus cars are among the best handling sports cars in the world. They can take on a curve at high speeds without losing traction. A Lotus Driving Academy instructor now takes the Evora for a test drive. The Lotus Evora is larger and more sophisticated than the Elise and Exige, but has the same easy handling and smooth ride.